Hello, boys and girls. This is your captain speaking, Mr. Bedley, and it's time for Excel lesson number 35 from the fourth grade Excel series. And today we're going to be learning about how to balance an equation, changing a not equal sign, which looks like that, into an equal sign, which of course you know what an equal sign is. And also we're going to be teaching you about how that whatever you do to both sides of an equation, it keeps it equal. And so we'll take a look at some examples there. We've got a little joke for you today here. And the joke is, what is the difference between a school teacher and a train? What's the difference between a school teacher and a train? Here we see like a little balance over here on the left. It's got a 7, and a 5. And then on this side it's got a 6 and a 3. Well, 7 and 7 and 5, that's 14. That's 19 altogether on this side. That's only 9 on that side. So you can see why it's tipping down that way, because this side is heavier. What could we do? What could we move from this side over to that side and make both sides the same or balance out and be equal? Well, if I move a 7 over to there, then this side would be left with 7 and 5, which is 12. And then the 6 and 3 would have a 7 to go with it, and that would be equal to 16. 16 and 12, well, then it would be tipping down too far this way because the 16 is heavier than the 12. And then my other choice would be another 7, which is going to come out the same. Or I could move a 5 over to there. Hang on one second. Let me get this erased here. And we'll keep going. So if I move the 5 over to that side, what would happen? Well, I would be left with 7 and 7 on this side, which is 14. And then if I put a 5 on here with the 6 and the 3, that's 9 plus 5 is 14. So both sides would be 14 and it would balance out. And they show that to you right here. They took the 5 and moved it over to there. This side is left with 14, and this side now has 14, so the scale balances. All right, why don't you try one like it? It's number 2 here. And just go ahead and do whatever you can do on it, and then I'm going to show you how to actually justify your thinking on that. So pause the video, do number 2, and then I'll show you how to put some work down below here to justify your thinking. All right, so you've already should have done this one. On this side here to start off, you're going to add it up and figure out that you have 16, right? Because, oops. 5 plus 8 is 13, plus 3 is 16, and over here you have 10. Well, what number could I move over to that side? If I move a 5, I'm left with 11 here, and then that would be 15. If I move an 8 over to the other side, I'm left with 8 here, and then that would be 18. If I move a 3 over to the other side, I'm left with 13 here, and then that would be 13. So I want to move the 3 over to this side here. Hopefully you figured that out. Now, how would we show our work on that? What we have to start off is 5 plus 8 plus 3, go ahead and write that down, is not equal to 6 plus 4. Okay, then above each one of these, the way I'm going to show my work is I'm going to show what this is equal to, just like I did up here. So that's 16 and 10. Now what I'm going to do is circle the number that I'm going to move over to the other side. And this problem, I'm going to move a 3 over there. That 3, by the way, is going to go in the check answer on your daily work. Then I'm going to rewrite the equation down below as an equal problem. 5 plus 8 equals, I'm moving the 3 over to the other side, so I'm not going to write the 3 there. 6 plus 4 plus 3. If you haven't written that yet, go ahead and write it. And then I'm also going to write what this is equal to. 5 plus 8 is 13 on that side. 6 plus 4 plus 3 is 13. So I write 13 equals 13. You can see that that balances. All the work that you see here, I'm going to go over that in blue. Basically in blue is what you have to do every single time you see a problem like this to justify your thinking. You can't just circle the number. You have to show this down below, which is writing it as an equal problem, a balanced equation, and writing what both sides are equal to. Okay, now that you've seen how to do that, see if you can do number 3. Pause the video, turn it back on when you're ready to see the solution. So you should have written over on this side 2 plus 2 plus 1 equals 4 plus 7 on this side plus 2. And actually that should say not equals because that does not equal each other. And the way you show your work on these, again, this side is equal to 5. That side 4 plus 7 plus 2. That's 11. That's 13. Okay, so what am I going to move over to make those equal? Well, I think I'm going to move a 4. And of course, you could go through and experiment with the different numbers and see what works. And then I'm going to write it as an equal equation. I'm going to write 2 plus 2 plus 1 plus 4, because I brought the 4 over from the other side, is equal to 7 plus 2. 2 plus 2 is 4, plus 1 is 5, plus 4 is 9. You have to write 9 down here, and you have to write 9 down here. If you did not show all that work, pause the video and do that right now. All right, here are two more problems that are just like the last ones. We just do not have a picture of the balance to go with it. So do these just like we did the problems 2 and 3. Pause the video, turn it back on when you're ready for the solutions for both 4 and 5. So you should have already done 4 and 5, and you add up both sides first, and everybody should write the number above of what each side is equal to. 6 plus 8 plus 3 is 17, and then you should have circled the 3 right there because you're going to move the 3, and then I write 3 plus 6 plus 2 plus 3 is actually equal to 6 plus 8, and that's what's left over here. That 3 moved right over to there. Okay, then 3 plus 6 is 9, plus 2 is 11, plus 3 is 14, and 6 plus 8 is 14. Make sure you have all that show work down there, otherwise you didn't justify your thinking. All right, on this next one here, we got 17 on the left side, and 8 plus 5 is 13 on the right side. You got to balance that out. You can experiment with the different numbers, but it's pretty obvious, I think, on this one you're going to have to move the 2. So now we write it as a balanced equation. 8 plus 7 equals 4 plus 4 plus 5 plus 2. The order doesn't matter. If you put that 2 over here at the beginning, any place on the right side, you have to put the 2. And then we justify and show why it's equal. 8 plus 7 is 15. And then 8 plus 5 is 13, plus 2 is 15 again there. So 15 equals 15. All right, these last couple of pages, I don't even know if they're on your paper or not, but it's going to explain, we're going to just work with you on what happens when we do the same thing to both sides of an equation. Let's take this equation here, 6 plus 6. That's an equation, believe it or not, if we just write 6 equals 6. And what if I did the same thing to both sides? Like, let's say I multiplied the same number on both sides. Well, if I did 2 times 6 on the left side, I put over here 2 times. And then on the right side, I also multiplied by 2. What do I get on both sides? I get a 12. So does the equation remain balanced when I multiply both sides by 2? Yes, it does. What if I divide both sides by 2? Does the equation still remain balanced? Yes, because 6 divided by 2 is 3. 6 divided by 2 is 3. What about if I add the same number to both sides? 6 plus 5, 6 plus 5. And if I and they're just picking some random number of adding 5. You could add any number you wanted to, but in the case of adding the 5, they both stay the same and they come out to be 11. What if I subtracted the same number from both sides? I subtracted 5, let's say, from both sides. Well, then both sides would be equal to 1. And again, the answer is yes, the equations stay balanced. All right, now that we know this, how could we solve for an unknown or a missing number in a math equation? The unknown here is x. Well, we all know by looking at that 8 plus 5 is 13, so x is equal to 8. That's simple, but what we're going to find out is that we can actually solve this in a different way. We can justify our thinking by subtracting 5 from both sides. If I take x plus 5 minus 5, well, the plus 5 minus 5 cancels each other out, because if I add 5 to something and then I take 5 away, but right back where I started from, and then if I subtract 5 from 13, I get 8, so I end up with this equation that says x equals 8. That's shown to you right here. Also, think of it this way. I've got a 5 and an x on this side, I've got a 13 on that side. They're equal to each other, they balance. So obviously there has to be an 8 here, or I'm moving the 5 over to that side. See, I'm subtracting the 5 here, and then I'm subtracting the 5 over there. And they show that to you right here. I'm left with an X on this side, and on this side over here I take the 5 away, and I'm left with an 8. So really my balance should look like X on this side and 8 on that side. To make sure your answer is correct, you simply put the number 8 back in the equation up here. 8 plus 5 is 13, and 8 plus 5 is 13 there, so 13 plus 13 equals 13. And now you have a different way to verify and to justify your thinking on why that number is equal to 8. And the answer to our riddle is the difference between a school teacher and a train. A train says choo 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 choo, and a teacher says spit out your gum.